Okay, everybody, welcome back. So, for chapter 2, what I like to do is make sure that you understand all of the resources that you have in your book. So, when you are in Pearson My Math Labs, you will see some of these items over here. I have a little bit more because I'm the instructor, but you can see here where it says e-text. So, when you see the drop down, you can open it up in here, but if you click here where it says video and resource library, the PowerPoint that I use for the first chapter, you can find here. So you can do all chapters and then click PowerPoint. You can click video and then you'll get all of them. So you see here, you'll see all of them, the entire book. Okay. So you can click on these and get the PowerPoint as well. And then if I uncheck that and then go to video, you can get all of the videos that match, right? And you'll get them all by section. So you can also, let's say you just want the section. So I would pick the chapter and the sections will pop up. Okay. So you can just filter it that way. But what I'm going to do is use the textbook for fractions. And you can also see here that you can use a study plan, for practice. You have video, there as well, and then you can click on homework. And you can do sample tests and quizzes and you can just use all these different tools. So, oops. So you can click on open my textbook. And then when you click on open my textbook, you can go to fractions. Okay. When I took any math course, no matter what course it was, I read my book. Why did you do that? Okay. So in chapter 2, right, fractions. Now I'm just going to show you, kind of give you a little bit of a tour around the book. You have, wonderful examples. So if you don't remember what you learned about fractions before, I would definitely use the book as a review for when you're about to take a test or whatever as well. And I'm not going to read this to you because it's so much information, but you can go through the examples. And then you have the did you know? Fractions also show division, right? So a lot of times when students ask me, how do I put a fraction in the calculator? Well, you just put 1 divided by 4. So here's 1/4, right? So this really means 1 divided by 4. And then you have some practical applications, and then you have more examples. So what I used to do is I would do the example. So it says visualize the fraction to identify whether it is a proper or improper fraction. Okay. And so the way that I thought about improper fractions means that the numerator, the actual number is bigger than the denominator. Okay. And then if you look here, it says part C, it says represents 4/4 or 4 parts when the one whole quantity contains 4 parts, right? So it said it is an improper fraction because the numerator and the denominators are equal. So that also constitutes an improper fraction. And then what's wonderful is the videos are here. That's what I love about Pearson. And then you have a stop and check. So I would do these practice problems. Okay. And then you can go through each section. Again, I'm not going to read these to you. You can go through them yourself. So what Pearson also does is separate the sections, right? So you see 2.2-1 exercises, and then you can go through, each section has the definitions and all that you need. And then you have a summary and you have an exercise set, which is also included in the PowerPoints. So what I'm going to do is I'm going to actually do problems from here. So I'll just pick random problems and I'll do those on my iPad. All right, so get ready. Let's go.
Okay, so bear with me. This program, it is a wonderful program, but sometimes it doesn't move around as nicely as I would like it to. But I'm just going to do certain problems. So, number one, give 5 examples of fractions whose value is less than 1. So, I would say 1. So, I would say 1/2, 3/5, 100 over 302. Okay. And then let's pick 2 more. Let's say 7 over 8. And then 41 over 55. Okay. And these are called proper fractions. Okay. I'm going to do 3 through 6. Identify each fraction as a proper or improper fraction. Oh, I'm not going to do all of them, but this would be a proper, right? And then 6 would be improper. Okay? And then let's do number 7. Write the improper fraction as a whole or mixed number. So I had to redo number 7. So you're just going to do the traditional way of dividing into 124. And then because you have a remainder, you're not quite finished. So you have to put a 0 in front of the 4. And then you're going to have 6 into 4, which is not possible. And you get a 0. And then you can add that decimal point. And then you multiply the 6 times 6, you get 36. And you subtract and you get 4. So your remainder is 4 again. And then you end up with 20 and 4/6. Let's do 12. So 10 into 19. All right, that would go 1 time, and then I would get 9 as a remainder. So this would be 1 and 9/10. Okay. Okay, so in this set, we are going to write the mixed number as an improper fraction. So I'll do 14. So what we do is we multiply this denominator to that. So we multiply the denominator to 5, right? We get 30, right? And then we add it to the numerator over 6. So we get 35 over 6. Let's do 17. So this would be 56 plus 3 over 8. So we would get 59 over 8. All right, reducing to the lowest terms. I'll do more of these. I just noticed that students have a little bit more trouble with these. So what you have to do is you have to think, what is the biggest number I can divide into the numerator and the denominator? And for this one, it would be 3. So this would be, so 15 divided by 3 would be 5, and 18 divided by 3 would be 6. This would be 2/3, right? Because I can divide 10 into both of those. This one would be 6, so I would get 5 over 8. And I'm running out of room, so I'm going to skip down to 24. And actually, I'll do 23. So this would be, let's see, 9 over 10. And then the last one would be 3 goes into, so 6 divided, no, actually it would be, so 9 goes into both. So 2 over, that would be 6, right? 9 times, no, 7. So 2 over 7. Okay? And then rewrite as a fraction with the indicated denominator. So if I would multiply 7 to get 49, 7 times 7, then I would just do the same thing. So this would be 28. Okay? And then I'll do 29. So what is 143 divided by 11? That would be 13. So 9 times 13 would give me 117. Okay, so you can just verify that. Okay, so number 30. It says, if 8 students in a class of 30 earn grades of A, what fractional part of the class earn A's? So that would be 8 divided by 30. Okay. And the next one says, find the least common denominator for these fractions. Okay, so these sometimes also give students trouble. So what I'm going to have to think about is what number is the smallest number that all 3 numbers can be divided into, right? So if I count by 16s, I always take the biggest number because it's the easiest way to do it, I think. So if I count by 16, I get 16, and then I get 32, and then 32 plus 16 is 48. Can 12 and 4 both go into 48? Well, that would be a yes. Okay, so it would be 48. Now, there's other ways to do it. That's my way of doing it. That's my shortcut. All right. Let's look at 34. So what number can 6, 10, 5, and 1 all go into? And that would be 30. Okay? So you just have to think about it. You might have to write all of the factors down. There's factor trees. I'm sure there's plenty of examples in the book that you could use. And then let's do 37. So 12 and 15. So what number? I would count by 15s. I think that would be the easiest way. Okay. So 15. Let's see. 15, 30, 45, and then 60. And I know that 12 does not go into 30 or 45. So does it go into 60? Yes, it does. So this one would be 60. Okay, so add, reduce to lowest terms and write as whole or mixed numbers if appropriate. So remember above are in number 32, 48 is the common denominator of all 3 numbers, all of the denominators. It's not the same exact problem, but so 48. Now, the way that I do this is I multiply everything by 48. And so 48 divided by 4 is 12, right? So let's see, 12 times 1 is 12, right? And then 48 divided by 12 is 4. So 4 times 11 is 44. And then 48 divided by 16 is 3. So that would be 21. And then I write all of that over 48. Okay. And you end up with, when you add all those together, so let's see, 12 and 21 is going to give me 33. And 33 and 44 is 77. I'm going to get, okay. And then you have to change it into a mixed number. It says it right there. So if I do it this way, 48 goes into 77 one time. And then when I subtract, oops, I gotta borrow 6, 17 is 9, and then I get 29. So I get 1 and 29 over 48. Okay. Let's do 42. So the common denominator is 15. So if I use the same thing I did just now, I'm going to multiply everything by 15. All right. So 15 divided by 5 is 3. So 3 times 2 plus 2 times 5. Okay. Over 15. And I get 6 plus 10 over 15, which is 16 over 15. And I'm going to get, once I divide, I get 1 and 1 over 15. All right. Okay, number 45, it says 2 types of fabrics are needed for curtains. The lining requires 12 and 3/8 of yards. And the curtain fabric needed is 16 and 5/8 of yards. How many yards of fabric are needed? So because they both have the same, or the parts of the fraction have the same denominator, I can just add the two whole numbers together. So 12 and 16, and then I can add the 5/8 plus 3/8 together. So I end up with, what is that, 28 and 8 over 8. And then I'm just going to end up with, 8 and 8 over 8 is going to be 1. So this is 29 yards. Okay. Okay, subtracting fractions. Now, again, I do these a little bit different, so I'm going to blow it up because I write really big. But I know what the common denominator is because 7 and 14 have some things in common, right? So 14 divided by 7 is 2, right? But I can't say that the common denominator would be 7 because 7 cannot be divided by 14 and it would create a fraction. Okay, so the common denominator is 14. So I write 14 over here. And what I do is, let me change the color. I can multiply 14 times 6, but instead I'm going to divide 14 by 7, and I'm going to get a 2. And so I'm going to multiply the 6 by 2. Now you get the same result if you multiply 14 times 6 and then divide by 7. You're going to get 12. Okay? So I just take care of that right away. And then I have 12 minus 5, right? And then all over 14. Now, I do multiply 14 over here as well, but 14 divided by 14 is 1. So I would be multiplying 5 times 1. And then I get 7 over 14. So I encourage you to pause the video and try 48. Now remember, you have to create 2 improper fractions first. So I'll do 50. So 4 times 5 plus 1 would be 21. Oh, let me go back to I like the darker color. So this would be this right here. This mixed number would be 21 over 5. And then 10 and 2 is 20. So it would be minus 23 over 10. And we know that the common denominator is 10, right? Make sure you understand that. And then 10 divided by 2, 10 divided by 5 is 2. So 2 times 21 minus 23 times 1. So what I did was I multiplied this as well by 10, but 10 divided by 10 is 1. Okay, so I end up with 42 minus 23 over 10. And like I said, I write so big that I ran out of room. So let's see, 42, let's do it the long way. All right, so we're still knowing those skills as well. So that'd be 19. So this would be 19 over 10. Okay, and it's reduced to lowest terms. It doesn't say I need to write it as a mixed number in the end. I could do that, but all right, so let me do 53. That's a little different. So 5 minus, let's see, that'll be 3 times 5 plus 2, which is 17 over 5, right? So we only have one denominator, so it has to be 5, okay? So in order for me to, I'm going to do this the old-fashioned way. In order for me to figure out how to place the denominator underneath 5, right, I'm just going to multiply everything by 5. So I end up with 25 minus 17 over 5. And what is that? 3 and 8, that'd be 8 over 5. Okay? Okay, multiplying fractions. So when we multiply, we just multiply straight across. So 5 times 1 over 6 times 3, which is 18. When you don't have a denominator and you just see the number by itself, you can write over 1 so that you don't get confused. So 5 times 2 is 10, and 1 times 3 is 3. And then it says we need to reduce to lowest terms and write as a whole number or mixed number if appropriate. So if we want to change this to a mixed number, we just divide. So we get 3 here, 9, 1. So this is 3 and a third. And then, of course, if you have a mixed number, you need to change it into an improper fraction so that you can easily multiply. So I'm just going to draw a little arrow here. So 9 times 6 is 54, plus 2 is 56 over 9. And then we multiply the other mixed number. So 2 times 4 is 8. So that would be plus 9. So 9 over 2. And then 56 times 9, I have no idea. So I can reduce, right, 56 and 2 to, what is half of 56? Let's just, I'm going to do it by hand because it doesn't come to mind automatically. I know 27, I think it's 28. Okay, so we got 2, 4, 1, yeah, it's 28. Okay, so this would be 28, and I can cross out the 9 and 9 because that's a 1, so I end up with 28, right? So 28 times 1 is 28, and then down here, that turned into a 1, that turned into a 1, so 28 over 1 is 28. And then I'll do 59 because it looks a little bit different. So 3 over 7 times 8 over 1 is 24 over 7. And you can change that yourself into a mixed number. All right, so finding the reciprocal of the numbers, all you do is flip them. You have 8, which is 8 over 1, so the reciprocal would be 1 over 8. I'll do 66, which is, this is going to be equal to, let me just actually use the equal sign. That'll be 61 over 12. So 12 over 61. Okay. And so on. On to reducing to lowest terms by dividing first. Okay, so we change it to mixed numbers if we need to. So anytime we have a fraction divided by another fraction, we flip the second fraction and we multiply. Now I'm going to show you how you can get the same answer doing it like this, or like we did before, I can cross out, right? And I get 1. So what is 12 divided by 4? It's 3, right? But if I factor out 4 from 4, I'm also going to multiply just 3 times 1, and I can also get 3. So if you look here, I have divided those out. Now you can only do that when you multiply. Do not try to do that when you're adding. It doesn't work the same. So be careful. Okay, so for 70, I'm going to change this into an improper fraction. So I'm going to get 15 over, I don't like that color. 15 over 2 divided by 2 over 1, right? So we will do 15 over 2 times 1 over 2, and we get 15 over 4. And then, of course, to make that a mixed number, I'm going to get 3 here, 12, 3. So this would be 3 3/4. Okay? Same thing with 72, 73, and 74. So just practice on your own. Okay, so for the applications, the word problems. So what I like to do when I do word problems is I always like to go straight to any numbers that I see. Now, it says that Bill placed a 5/8 inch plywood and a piece of 3/4 inch plywood on top of one another to create a spacer between 2x4s. The 2x4s are really not important. So even though they're numbers, they're really not important. And then, but the spacer was 1/8 inch too thick. How thick should the spacer be? So what I'm going to do is I'm just going to set it up. I don't have a lot of room to write here. So 5/8 plus 3/4, right? And then we need to subtract 1/8, okay? So what I'm going to let you do is figure out what that is, okay? And then I'm going to concentrate on 78 because we have a dollar amount. And it says here, Soul's Hardware and Appliance Stores selling electric clothes dryers for 1/3 off of the regular price of $288. Okay, so how do we figure that out? So I'm going to have 1 minus 1/3, which, equals, that's my hand in the way, which equals 3 minus 1 over 1/3. Okay, so that would be 2/3 of 288. Okay. And because I don't have a lot of room, I'm just gonna, and then I can make this easier if I do 288 divided by 3. I can, if 3 goes into 288 and it does 96 times, then I can just multiply 2 times 96, right? And so It says, what is the sale price of the dryer? Okay. Oh, I don't have a lot of room, so that would be $192. What is the sale price? Okay. Now, that's one way of doing it, but I would like to just go straight to it, right? So 1/3 times 288 equals 96, right? That's $96. And then I would just subtract the 96 from 288. So 288 minus 96 is also $192. So that's two ways of doing it. And then lastly, I'll do 80. That might be, since students usually attend college, certain financial aid students must pass 2/3 of their courses each term in order to continue their aid. If a student is taking 18 hours, how many hours must be passed? Okay, so then that's just 2/3, right? Times 18 hours. And you can write over one, I don't, okay? But if I divide 3 into 18, I get 6. So 12 hours, okay? Also, remember to always look at what the question that any word problem is asking. Don't answer questions that it's not asking, okay? So I hope that this helps. This gives you the entire chapter, this entire mini lecture. And, practice makes perfect. When I learned how to do complex fractions, I just did many of them. I did almost the entire section of them throughout the book. And then I also, if I got stuck, I always refer back to examples. So I recommend you doing that. And as always, thank you for watching. See you next time. If by chance you have difficulty with anything that I went over, don't hesitate to leave me a comment or you can email me.